Hi friends, this is Arun. In this video, we'll have a look at what is an abstract data type and why we need to go for it. So this presentation more of a conceptual thing rather than a hands-on stuff. Okay, but it is very important and very basic, elementary, but it is very important. Let's start with some example or analogy. For example, here there is a car picture. It's Bugatti. Most of the people knows it. It's the fastest car in the world, and it is a sports type, blah blah blah, all those stuff. Okay, let's assume you buy a Bugatti car, hmm, and you own it. Do you need to understand in which material it is designed, or do you need to understand the internals of the engine to drive that? Obviously no. Okay, all you need to know is like how to put a gear, how to press the gas pedal, how to steer the uh, wheel. Okay, these are the basic things which you need to know to drive a car. Okay, rest of the other details are abstracted from you. Okay, you just put a key hole and then press start, it starts. That's it. Okay, or there will be a push button where to start, you will push the button and start it. Okay, so like that, in real world most of the internal implementation is abstracted from you because of many reasons. One is to hide the complexity from the user, and also to maintain the trade secret of their own products. Okay, these are the two plain reasons. The same thing applies to a real world as well. So in this case, I don't need to be a mechanic or I don't need to be a designer to drive the car. The same way, if you write a code, and the user or the consumer of the code doesn't need to be an expert in using or consuming the code. Like you write a helper library, okay, and give it to someone else. He doesn't need to understand the internals of the library to use the library. Okay, all he need to know is like what are the parameters he need to pass, what it does, and how to use it. That's all you need to know. Like same as the analogy of a car. The same analogy goes for any other real world examples like TV, fridge, or whatever you know it. Okay, so this is the reason why we go for the abstract data type rather than the specific data types. We focus on more of a abstract data type. Okay, so in the next slide we'll focus on the defining the term abstract. So what abstract data type mean? So in Latin, abstract means pull out or hide the essentials. Okay, so hide the details. Okay, show only the essentials. So that's what it means. The same thing will apply to our code as well. Okay, so that is abstract. And what is a data type? So obviously, if you have used any programming language or seen anywhere, you might have heard the word like integer, float, character, string, all the stuffs. Okay, those are the data types in the language. So what we are trying to convey here is like abstract out the data types to the consumer. Say only the generalized thing so that he happily uses your data type like any other data type which is present in the language. Like he should use your whatever code you are giving like a normal integer or a float, so that he'll be happy and he'll be focusing on his own business solution rather than fighting to understand what your problem, what your thing does it. Okay, let's go back to the previous example. Like we said, right, like the RTO will give license if we are able to drive one car. His assumption is like all the cars of the are of the same model, and the guy or girl could drive the other cars. Okay, what is the reason for his assumption? The reason for his assumption is the standardization. So if you look into the cars, most of the cars are standardized. Okay, so all is all their operations and the behaviors. The same we are here applying it for the softwares as well. Like ADT is nothing but a combination of a property and an operation. What is a property? Let's assume I am a person. So my properties are my color, my name, my height, my weight, my sex. All those things are my properties. What are the operations? What are the things I can do? I can code, I can swim, I can run, I can eat. Okay, so I can shit. All these things are my operations which I do it. Okay, so as if you're writing a code for representing me in a program, what you will do, you will try to write abstract class and give a name like a human or a person or a living thing like that. You give it and give that function or whatever it is to the user to use it. So whenever he wants to create a in or create or represent my self in his code, what he will do, he'll use that. Okay, So he'll use that and represent the code. For example, properties are always represented with the data, and behaviors are always represented with our operations, our functions, our methods. Okay, so if you see and just a little bit into it, it's more towards the object oriented programming. Okay, in object oriented programming, we call this as a class. Okay, don't scold me for explaining the class. You are like going around, beating around the bush like this. You're saying that. No, it's not about beating around the bush. It's about bringing the concept into the place. So the concept is like standardization, okay, and abstraction. So if you want to abstract something, first you have to standardize the things, okay, and that is the key thing. So ADT couples the data and the operation so that you can give us a single thing. For example, instead of giving TV and then giving remote separately, we give both the things to you as a single entity so that you can use it as and when you get it. So the object orientation emphasis more on the abstraction and the formal description of something, and it is independent of the programming language. For example, some languages will not have the class and classes and objects. So in those places, we use other mechanisms to achieve this. For example, if I want to write the same thing in C, I use structures and then the functions. Okay, whereas in if I go for any functional programming, I achieve it with the different mechanisms. Okay, that is the reason why we didn't say that as a class and we didn't go for any language implementation here. Our main goal is to design by contract. First we define the contract, what are the behaviors, what are the attributes which is belonging to the project object. From there we'll start writing the implementation based on the language. If it is Java, we'll implement in a different way. If it is C++, we'll implement in a different way. But before that, we should say what it does. Okay, let's assume I have a stack. We have seen stack a lot of things, right? I can implement the stack data structure with the array or with the linked list. Both the things are possible. If I'm a new programmer, my first, or I wouldn't say new programmer. If I know my stack is a fixed stack, what I'll do is I'll go with the array, which is simpler and efficient to use it. Okay, if I'm about to design a growing stack, either I'll go for a resizing array or a dynamic array, or even I can go for a linked list. So the abstraction of what I'm going to use it internally to store the values of a stack is hidden from the user. All you need to know is like, hey, this guy can store data of some type, and then he can control with the options like push or pop. Let's take the person class. Let's assume the person class, I have a variable, I have a property called age, and if it is kept as public, so and the trouble which I'll have is like somebody who's mischievous or who's not knowing the meaning of age might set around 2000, and there are people who are claiming who's having 2000 age as well, but let's in the normal case it's not that. Like the same way, if I have a student class, so the operations would be like set name, get name, courses, all those things, and in the courses I can control what are the courses that belongs to that student. If the student is of certain class, I can control all those things. The same way with the list as well. So list is nothing but an array, but with a controlled way. Like I can expose where to insert, what to do it. Okay, one of the control list is the typical stack. Okay, stack or queue is one of the examples. So in this case, like if I want to have an operation which puts the data in a certain position, so I can write on my own. So if they give beyond the limit, let's say I want to insert in 1000 place, but I know my list sizes of certain. Okay, so in that case I can't use it. The same way with the stack. So stack is a standard thing, last in first out, as we discussed in the earlier. So here I have a insert, push, or push and pop operations. Okay, which is also remove and nothing, and top and make empty. These are the operations. Internally I can use an array or a linked list, as we discussed earlier. Okay, the overall summary is here is the point is all about like abstracting the internals. Okay, that's all. That's a single point which I am trying to insist from the first. So you design by the contract and hide the internal implementation. You use any programming language, it doesn't matter. Okay, so when you design a contract, it is always good to it is always good because it clearly communicates what you thought, what your thought process is and what your expectations are. Okay, without that, like, you will be implementing something and the other person would be expecting something. Okay, and the ideal case is like all the data in a class should be private and they should be accessed via getters and setters. The reason why we are having getters and setters, like the control, so you can set a random value. Okay, and ultimately a contract. Okay, ADT should provide a contract. These are the key things you should take away from this session. Okay, nothing else big about it. Okay, thank you friends, bye bye.